Paper is a unique material, and there are many types of paper. So I want to take some time and discuss types of paper, and then also I want to walk through building a full paper preset from scratch on a 360, 370, so you understand the process and then what to look for and some of the nuances of paper, because paper performs a little different than some of the other materials. What I have here is an IntelliCoat paper. It's a 200 gram. It is called a Eco Satin. It is a perfectly printable paper, but it's going to take a little finesse in certain settings to have it print properly. With some papers, it may really be necessary to make them from scratch. Build your own custom preset if existing presets aren't sufficient. Papers have different coatings. There's coated paper aqueous, there's solvent coated papers, there's universal coated papers, there's offset coated papers, there's uncoated papers, there's wet strength papers. Each of those will have different characteristics. Different thicknesses of paper can have different characteristics. You can print on cardstock with a latex printer, and each cardstock might have sort of different settings, different vacuum levels, and slightly different surface coatings on it that will perform differently. So depending on what you're printing, and considering the strength of the printer is really the versatility, just the breadth of papers you can print on, it's going to be helpful to be able to walk through the steps, because there's so many papers out there and so many choices, it may be helpful to know how to do it yourself in some instances. So this is a full paper preset that we just made. And I want to walk through the steps. First, I'm going to go into the panel and show you, how to initiate a new media start, and then what the settings we used and what to look for, and then the results we were able to obtain. So first, we go onto the panel here, and the substrate library we're going to touch. And then once in substrate library, we're going to choose a paper, and we're going to create new paper. Now there's some choices here. You have a generic paper. That's going to be a little different than a coated paper, and then a backlit paper is really different. Backlit paper is going to put a high density ink load on. There's not too many backlit papers out there. There are a couple of them that work pretty well. Fibremark makes one and Neenah makes one. But we're going to stick to primarily your best setting here is usually generic coated paper, and that's what this is. So we're going to create a category, and we're going to more or less get some basic settings for this particular media. So since we've already made this, on the panel here I have the settings that were done for this particular IntelliCoat poster paper. And one of the things I started with was running it at 12 pass. Now 12 pass is about the slowest of your front lit speed modes. Usually at 16 pass you're looking generally at fabric or backlit. So on a front lit, the slowest I really want to go is 12 pass. But I'm going to start at 12 because 12 is going to give me the best the printer can do on a paper, and then I can always print other modes that are faster. But I'm going to start with a 12 pass. 12 pass is also going to tell me that if it prints really well in 12 pass, there's a pretty good chance it will work in 10 and probably even 8. If it doesn't work very well in 12 pass, there's not much point in trying 10 pass or 8 pass, because they're not going to perform well on the paper. And since there's so many different papers, I don't necessarily know how well this paper is going to perform out of the gate. So we chose 12 pass, and then once it's in 12 pass, I'm going to print this chart. Now, I already know in advance that paper can be temperature sensitive. If you put a lot of ink down on paper, especially using our optimizer system, the paper has a lot of liquid, in this case water. And that water is sitting on top of the paper. If you put too much water on the paper at too high a temperature, it buckles, or it cockles, or it causes other image quality problems. And even adjusting the vacuum to increase the vacuum may not be able to smooth it out. Many papers, I'm going to run under 200 degrees Fahrenheit. Some other papers, wet strength papers, other characteristics of other types of papers with certain coatings can take more temperature. But this being sort of an unknown coated paper, 200 gram, my guess is it's going to run a little low on temperature. And I was quite right on that. So the temperature that we chose for this is 187 degrees Fahrenheit. 12 pass, 187 degrees Fahrenheit. We left the default settings for the coated paper with the exception of increasing the vacuum. We have the vacuum set here to 160 to 65%. So we have a reasonably strong vacuum to hold everything down. The first chart here is determining, can you put that much ink down? Now, if it scratches a little on the first part of this print, don't get too bent out of shape. It's not the end of the world. It happens. What we're doing is some of these are not going to be acceptable for the amount of ink, either because of the hazing or the sort of lawnmower effect on the solid color, or possibly coalescence. But normally the problem is if you put a lot of ink down on paper, it tends to buckle or cockle or scratch, and because there's so much water there, it's not going to go through the printer effectively. So between the image quality study, trying to make sure we have a nice, smooth, solid, rich black in the global ink limit, and checking the coalescence, and looking at the bleed chart, and then based upon the way the paper is performing, we decided to go with 90%. 90% will work with this paper. If we try to put 120%, what's going to happen is either it's going to scratch or it's going to cockle. It simply cannot hold that much water and go through the print path effectively. Don't worry too much about it if you see some scratches on there. Sometimes those are a result of the heavy ink load in the bottom and they carry up. When you choose 90%, look at your charts that come after this. In a lot of cases, that lower ink limit is going to allow everything on the paper to run more smoothly and the head strikes will not be there anymore. So after choosing 90%, we then printed this chart. Now this chart is a closed loop color calibration. That's what this is. This is designed to do two things. One, it determines your densities and also determines your ink restriction and your linearization. What we're doing is creating a single chart that will allow me then to create a fingerprint for this media. This is what the chart looks like on a 360, 370. Now the 310, 110, 330, they look a little bit different, but it is the same effective chart. It's just a little smaller and it's over on this end. This chart is the key calibration chart for all latex printers, 370, 360. This is what you do after you download a new media. You hit calibrate, it prints this chart, it establishes baselines, there's your fingerprint. We did this for this media set at 90% ink, 187 degrees Fahrenheit with 65% vacuum. And I have a little scratch off the front end, which could have been a little deformation from the tail end of this print, but by and large, everything looks good. Everything printed well. If you see a lot of scratches here or marring or something like that, you may have to go back and rethink your numbers here and then run this chart again. Also, sometimes it is helpful if you do this chart to roll forward a bit. So do this and then close it, open it back, roll it forward, open it back up and then start the process again, having some distance here. Because if the tail end of this is deformed or has a little heat put on it, it can affect this and then this will not perform correctly as it goes through the printer. There are some papers, not all, but some papers where you can't do this chart effectively because when it prints it, it rolls it back into the print path, tries to read it, and either tears it or scratches it. That does happen. There are some papers that are just too sensitive to the cockling that they can't go back into the print path. Those are what I call forward-only papers. And in those cases, you will not be able to do a color calibration. Now with the latex printer, even if you can't do the calibration or the ICC profile, the printer will always use a generic category calibration and ICC that it will apply automatically. So it will still be able to print, and it will still be able to print using both a color calibration and an ICC, but that calibration ICC will be from another generic media based on the category you've chosen, in this case coated paper. Most of the papers if you get the density right and you're not putting too much ink down, you can get this to work just fine. Sometimes it takes a couple tries. Sometimes it takes rolling it forward a little bit so that the paper you're printing on has not had any heat applied to it, but usually you can get this to work. Sometimes I do use the edge guards. They'll help stop the paper from getting caught as it kind of rolls back and forth. Now, once this is done, now what your printer will say, what your panel will say, is it will say OK. It will go from saying recommended to OK. That means you're building a new one. You're building something from scratch. Now it has a fingerprint. This is day one. This is its birth date. The next print, which is in here on the final side, which is building an ICC, is this chart. Now, sometimes this chart is not very easy to print on a paper. The reason why is you're printing a lot of ink across the full width, but if you get your density about right, and you don't put too much ink and your temperature's there, this is entirely possible to print. Normally on things like banner, adhesive vinyl, most canvases, wall coverings, this is a breeze. This is absolutely flawless, never any problem. But paper, because of the amount of ink, and depending on the type of paper you're printing on, sometimes this can be problematic. In this case, there's no issues. It read the chart, it brought the chart back into the printer. Instead of saying generic, it now says custom in the little section on the panel. And I built a full end-to-end preset for a paper on the 360. I wanted to take the time to go over the paper presets because paper is a little tricky. It does require, in some cases, some papers are going to be a little difficult to get the settings just right. The general rule for me has been a lower temperature, a slower speed, with some vacuum applied to hold everything down, and generally the paper runs through well. Now, most of the papers I'm printing on are really offset coated. I'm printing offset coated papers which are not specially developed for latex or anything else. And in fact, latex is about the only technology that can print on those papers. But it may take some finesse. Once you leave the media locator and start going out into your own and buying papers, knowing how to do this is going to be a big help. The last chart that I do is I pick an image or a couple images that will show me issues. They'll show me that everything printed okay. So in my case, I have a particular calibration chart that I use. And this calibration chart has text, it has blockout text, transparencies, grayscales, Pantone colors, heavy colors, backlit type prints, detail. It's trying to show everything together and then print the full width of the paper. Sometimes we found that if you print narrow rolls of paper, the paper may remain fairly stable. But once you start printing the full width, like a 54 or 60-inch roll, that's when the problems start. Because in the middle of that paper, it comes up in the curing zone, rises, and then touches the top of the curing zone because you're bringing all of that ink, or excuse me, all of that liquid into the curing zone at one time. And when you heat it, it comes up right in the middle, like a little sail. And it touches right down the center, and you'll get little scratch marks. So after I dial in a paper, I send some prints, the full width of the paper, and sometimes I'll run a fairly long job. I want to make sure that I'm testing that paper with a full width print with a good amount of ink to make sure everything is nice and smooth. Now, you can put it on the take-up roll, and the take-up roll will help somewhat. But mostly what I'll try to do is make sure everything works fine without the take-up roll. And then if I use the take-up roll is just an additional assurance that it's going to pull it down just a little bit more, and it's going to give me just a little more of a window to be able to print everything just fine. So that is end-to-end paper preset building on a 360 for, say, unknown papers, strange coded papers, unknown coded papers, universal coded papers, offset coded papers. There's a lot of papers you can print on. This is the kind of steps that we do to make sure it works. From time to time, you may run into a paper where if you want to build the calibration or the ICC, you may have to use an external device. From time to time, I use the i1 because I can't get it to print that ICC chart the full width of it without having issues rolling back into the printer and then reading it. It just isn't stable enough for it. And in those cases, I only use an I1. I roll it forward only, and that's what I call a forward-only paper. Most of the papers on the Media Locator, none of that's required. They print very solidly.